Hello and welcome to Teen Topics, where you'll be taught all you need to know about circle theorems. So a circle theorem is basically finding the angle within a circle, which has another shape inside it. These shapes are generally not drawn to scale, which makes it that little bit more difficult. But don't worry, in the next few minutes you will learn all you need to know about circle theorems. Okay, starting off. A chord is a line that lies anywhere below the diameter that goes from one side to the other of the circle. In this image, the perpendicular bisector of the chord passes through the centre of the circle. Number 2. Here we have a semicircle. Say we put another one on top and put a random triangle inside this half and name these angles A, B and C, then this angle B will become 90 degrees. But this is no fluke. Even if we have this triangle instead, or maybe even this one, they will always be 90 degrees. In fact, put any triangle here and it will still add up to, yep, 90 degrees. Number 3. A tangent is a line that passes the outside edge of a circle. When this line is touched by the radius, that means the angle will be 90 degrees. Number 4. A subtended angle is almost like our eyesight. When we look at an object, our vision is focused on that. Taking this tree and this man for instance, the subtended angle is 22 degrees. The subtended angle is basically the line, arc or object opposite to the inner triangle. Number 5. Angles in the same segment subtended by the same arc are equal. For example, ABC is the same as ADC. Number 6. When you have an arrowhead shape inside a circle, the inner angle here is twice this angle at the circumference. Number 7. The diagram shows a cyclic quadrilateral, which is a four-sided shape with all of its corners touching the circumference. What is different about this is that the opposite angles both add up to 180 degrees, so A and C would add up to 180, and B and D, same thing. Number 8. Going back to the tangents, if you do not remember, go back to number 3, then the lengths of the two tangents would equal the same amount. To explain that with a visual guide, length AB is the same as AC. Number 9. The angle between the tangent and a chord is equal to the angle in the alternate segment. This is also known as an alternate segment theorem. Here was quite a confusing looking sum that you are likely to get in a maths exam. Have a look at this image and have a go. Can you do it? Pause the video and see what you can get. Okay, so the sum we would do is A equals 180 minus 70. Divide this all by 2 and this will equal 55 degrees. As some people already know, the base of isosceles triangles will always equal. Now we get the 90 at angle B and take 55, which equals 35 degrees. How was I able to get this 90 degrees? Well, as previously explained, when a radius and a tangent meet, this creates a 90 degree angle. Now we have 35 degrees from the previous answer, we times that by 2 to get 70. Now we take it away from 180 degrees. Finally, we divide that 110 by 2 to give us 55 degrees. This is the angle marked D. Congratulations if this was your answer. If there is anything you do not quite understand, give me a shout out in the comments down below and I will happily answer your question. If you found it interesting or helpful, then maybe consider pressing that free little subscribe button down below. It really helps me out a lot.